So this session is being recorded and it will be available as a resource after the event. I'll just give a few more moments for our audience to join in. Great, well, let's get started. It's a little after 1 o'clock, so very warm welcome to all our audience to this Lunch and Learn webinar from the Supply Chain Sustainability School. This one is entitled The Do's and Don'ts of Offsite Logistics. And I'm delighted to welcome guest expert speaker, Rory Bergin from HTA. Afternoon, Rory.
Thank you, David. I'm not sure quite about the expert tag, but I'll take it. I'll take it.
So what we're going to do this afternoon, ladies and gentlemen, I'll run through a little introductory piece about some of the work that the school has been doing over the past few years to develop some learning resources to support the industry as it transitions from traditional construction towards a more modern methods of construction business model and how we can support you. I'll then just very quickly run through a few scene setting slides about some of the topics that we cover in our workshops and our training. And then I'm going to hand over to Rory to talk about some of his real world experiences on some very significant volumetric modular offsite projects and some of the things that he and his team need to think about as designers that perhaps are peculiar to the new MMC model, as it were. So I'm going to get through my piece fairly quickly because I really want you to hear more from Rory than from me. So very quick introduction. I'm Dave Emery from the Supply Chain Sustainability School. I'm responsible for helping create and deliver training materials around offsite construction and digital construction. As I said, I'll talk you very quickly through the materials that we have a quick overview of offsite logistics, and then I'm going to hand over to Rory, who is a partner at HTA Design. And his piece will be called The Do's and Don'ts of Offsite Construction Logistics. So very quickly, just to go through some of the background to the materials, the Supply Chain Sustainability School was sponsored by CITB in a project called Improving Skills in Offsite Construction. We partnered with the MTC in Coventry Manufacturing Training Centre, and we were accredited by CPD and NOCN Group. We, as always, when we develop materials, we look to the partners of the school, those subscribing businesses, who we know have in-house expertise that can help us shape, deliver, and pilot our training materials. So I just wanted to acknowledge the help of a few businesses there. So when we set about developing these materials, we felt there were probably 6 disciplines or professions that we could help and steer individually, and that they were designers, QSs, stroke cost consultants, logistics people, site managers, procurement, and project managers. And what I found very interesting is we deliver regularly on each of these topics in either this format or in longer workshops. And what I find very interesting is that we get lots of architects and lots of cost consultants attending anything we do around logistics. And I think the reason for this is logistics, or the successful logistics of an MMC project can be influenced by lots of factors. And I think the early stage consultants, those designers and cost consultants, need to familiarize themselves with what those factors are in order properly to be able to advise their clients. So when we go through the training materials, we look at the various MMC categories, of which there are 7. We look at the concept of construction industrialization, which is thinking in terms of not only the knowledge of what we ourselves contribute to a project, but how that impacts on other people in the whole design, deliver, install, and operate circle. We also take a look at the new Design for Manufacturing and Assembly overlay, to the RABA plan of work, which recommends now the early engagement of an MMC advisor. And we consider the aspects around planning your project, transportation of modules and equipment, lifting and installation, and so on. And we try and get over the fact that logistics needs to be considered at an early stage. It's very, very important, and it's not something that you can just leave to the end of a project. So I think I've said enough for now. What I'd like to do is stop sharing and hand over to Rory. So Rory, you've got the dual task now of sharing your presentation and of course introducing yourself. While Rory's putting his display up, please in the audience, you will see on the bottom of your screen a Q&A box. We'd be really happy for you to type in any questions that you've got for Rory, and we'll try and deal with those towards the end of this session. So Rory, I see your slide deck is up. I'm going to hand over to you.
Thanks, David. How long would you like me to talk for? Because we want to leave some time for Q&A.
I think if we can go about 25 minutes, and then we'll leave 15 for Q&A and roundup. Thanks very much.
Okay. All right. So my name is Rory Bergen. I'm a partner at HTA Design LLP. So we're a design practice, primarily architecture, but also other disciplines. And we have been involved for the last 12, 13 years or so in a lot of large scale volumetric projects like the one on the screen. So I'm going to talk a little bit less about the projects today and more about, as David said, the logistics of delivering these types of projects, which we've learned quite a lot about in our involvement, and when you need to think about them. Almost as an aside, a piece of work that we did last year with others, including Hawkins Brown, L&Q, and Virtual Viewing, we created an app called the DFMA Toolkit, which is available on the App Store. From experience, it works better in iOS than on Windows, but I recommend you download that because it will cover quite a lot of the issues around logistics in general, but also at each stage of the RIBA plan of work. So things do change over time. So that tool will go into that in a little bit more detail. So I recommend that to you. For those of you who don't know us, we're a 250 plus practice based mainly in London, but with offices around the UK, and we cover a number of different disciplines. I mean, I think in particular we focus on designing places, and we like to deliver them. So we like to design and construct places, buildings and the landscape, rather than being sort of concept designers and then handing it over to somebody else to deal with. So consequently, we like to have a technical knowledge and an understanding of how buildings are actually delivered so that we can design them and also think about some of the issues that are going to arise, including the issues around logistics specifically. And our work covers sort of housing at all scales and sizes and location types. Now, one of the main benefits of designing for offsite in general is the potential savings on construction program. So typically we can deliver a building in about half the time that it takes a traditional contract to be delivered. So if it was originally going to be 2 years, we can sometimes get it down to a year or even less. If it is going to take 4 years, we can get it down to 2 and a bit. So the decision to go for large scale volumetric methodologies means that you've got to do quite a bit of due diligence at an early stage to check, can you actually deliver the building using this methodology? You can think about it in theory, but in practice, can you actually deliver it? And we have worked on some projects which were designed to be built this way and turned out to be difficult or impossible to do so because of some fairly fundamental problems, not necessarily with the building itself, but with how you actually get modules to the place and how you deliver them onto the building site. So just to illustrate, typically we can deliver perhaps 2 buildings within the same period that a traditional contract takes to deliver 1. And there are all sorts of benefits around it, particularly around safety, which is, I think, a big issue to do with logistics. How you move things, how you move big objects from place to place has a big impact on health and safety. And taking work off-site and moving it into a factory has a big impact on the well-being of the workforce and their ability to work carefully and quietly and safely on a piece of work that's in front of them. And in terms of the sort of scale of projects, most of our projects are at the right-hand end of the scale. So their volume, well, most of the projects I'm talking about, in terms of a proportion of our practice, I would say half or more of our work, of our output, is delivered as traditional buildings, some with panel systems and pod systems. In fact, those are quite normal now. So it's probably 20-25% of our output is delivered as volumetric modular buildings. So it's by no means the only thing we work on. And to date, we've built around 7,500 units of one kind or another, whether it's hotel bedrooms, student rooms, or parts of an apartment building, or full apartments to date. And the future tallest modular building in the world, well, it's actually now topped out, so it is the tallest modular building in the world, College Road in Croydon, which is beside George Street. So at 48 stories, it's the tallest modular structure completed on the planet. So the sort of that typical process is that we start building in the factory at the same time as we start work on site. So we build the foundations. Usually there's a podium structure and a slip form core. So those are usually built using traditional methods. But as those of you who have experience with these will know that this happens very quickly. So slip form cores rise at a rate of usually a floor per day. So it's a sort of continuous pour. So a very quick system. So the work is planned, so by the time the core and the podium are complete and have cured enough to bear the loads that are going to sit on them, then the modules start to arrive. So the modules are being made in the factory from the same time as we start on site. So between 12 to 16 weeks or so from the time of starting on site, the modules start to arrive. So the podium and the slip form core need to be in place. And there's an interesting and fairly complex logistical path between all of these, because before you make the decision that this is going to be a volumetric modular project, you have to ensure that the modules can get there. So that there is a route from the factory to the site that is stable enough, wide enough, etc. So usually what happens is somebody drives the route with a camera and records it so that any possible obstacles can be identified. So usually things like railway bridges, pedestrian bridges, planned roadworks. So it's important to have a second alternative route if the first route should be interrupted. But also in terms of insurance and risk approach to projects like this, it's always important to have a plan B. So, if there's a problem with the factory itself, how can you manage the logistics of that? If the factory has to shut down for a week because of, a small fire or something else happening, how can you deal with that? And that's usually dealt with by having a buffer of production. So you ramp up production at the beginning so that you've got some units in store, and then you start delivering start delivering units to site. And also what we usually do is we usually have a location close to the site if the site isn't big enough to contain storage, a location on site or close to site where some units can be delivered overnight. So generally it's easier to deliver large loads at nighttime. So you have traffic being delivered to this point on site overnight, and then they wait to be then driven to the crane point to be erected onto the site. So sometimes modules will sit on a trailer for 24 hours beside site or near to site until such point as the crane is ready for them. So it becomes a sort of a circular thing where trucks are constantly moving either from the factory to the site or from the site back to the factory, or waiting to deliver their load to the crane lifting point. There's also a sort of an interesting complexity here about the manufacturing process, because if you imagine you have to deliver this set of modules, but you also have to temporarily store those modules, then what happens is you build this set of modules on top first, and then they go to the bottom of the stack. And then the last modules on that stack are the ones to be delivered to site first. So the factory production is also geared around the process for how you're going to buffer the loads and then get the loads to site. And then after a period of time, and buildings like this tend to rise at a rate of 10, 12 modules per day. So that might be a full floor, or it might be half a floor. So you might have a floor every 2 days or a floor every 3 days. So then you have, once enough time has elapsed, you install mast climbers typically. And then the mast climbers can provide a working platform for follow-on trades to work on completing the fireproofing between modules and then applying the facade. So on taller buildings, we tend to have, as you'll see in some photographs later on, we tend to have 2 sets of mast climbers. So one at the top, which is dealing with fire sealing and weather sealing, and then one lower down the building, which is dealing with the finishing elements of the facade. So the sort of the on-site logistics are typically fairly different from a traditional building. Although some of the buildings that we've delivered have been built using scaffolding for the cladding, because for a planning reason or cost reasons, hand-laid brickwork was appropriate. So it's still possible to do that, because you still build the core of the building so quickly that when you follow on with scaffolding, it doesn't slow down the delivery. So the cladding comes off the critical path. And then in terms of the sort of module installation, so here there's a sort of a series of diagrams sort of showing a typical sequence. So you have an initial module placed, a second module is placed alongside it, fixings are made between the modules, and then seals and then fire seals are made, and then more connections for the next module. The roof of the first module is prepared for follow-on modules, more connections, more seals, more fireproofing, and so on as the building moves up. And then work is done on the facade to make sure that the points of connection and so on are sealed. So this is quite a specific process, and it'll vary a little bit between different manufacturers. Each manufacturer at the moment has their own process. Although I think over time, those differences will probably diminish as people work out the best methodologies to use for typical building types. So for high-rise buildings, there'll be probably one common methodology. For low-rise housing, there'll be another methodology. For healthcare buildings, and so on. So depending on the use and depending on the things like fire requirements and so on. I expect these differences to diminish over time. Not all modules that are delivered are the same. So we're not working in a world where there's a huge amount of standardization and between buildings. We try and have as much standardization on the building itself as we can manage. But from building to building, there are often quite big differences, and that's because sites don't come in square or rectangular shapes. So if you're building on a triangular site, you end up with buildings that have triangular corners or triangular shaped modules or whatever. And each one of these, is a real module that's been installed many times on real buildings. For those of you that are puzzled by the long rectangles, these are corridor modules. So sometimes we use a full module to make a corridor, and sometimes it's a two-dimensional cassette. So that varies from project to project. Excuse me. So again, the sort of logistics and the trailer size and the handling and so on that are needed to move modules from factory to the site also need to be able to cope with variations in load lengths, load widths, load complexity, where the lifting points on these modules will vary from one module to the other. So the crane also has to have a rig which is capable of handling wide variations in load, shape, and weight. So some of the very wide modules, which sometimes are necessary for one reason or another, may need escorting on the roads. So they may need a vehicle in front or behind or both, depending on the size and dimensions. But this is something we try and limit on the buildings that we do, and we understand those dimensions before we start. But it's just another quite important logistical consideration, and it does have an impact on cost. So the more expensive, the wider the load, the bigger the load, the more expensive the delivery mechanism is. And if you have lots and lots of large wide loads, then that really eats into the financial viability of this method of building. So you want to keep module widths down to something that can usually be delivered by a single vehicle when possible. But at the same time, you want to be able to design buildings which are the most useful possible for the use that they've got. So, we try not to let the factory production drive too much the buildings, because we don't want to end up with buildings that are made of lots of identical modules, because that tends to compromise the spaces. So, we don't have bedrooms. Typically, we don't have bedrooms and living rooms which are the same size, because the spatial requirements of bedrooms and living rooms are quite different. So we tend to avoid the argument that every module needs to be the same size. No matter how stringently some manufacturers may say that that's what they want to do, we're focused on delivering good quality housing for the people who are going to live in the building. The demands of manufacturing are rather short term. The demands of people living in building are 60 to 100 years. So we try and prioritize the latter rather than the former. And I think too that in terms of how we construct the buildings, there are issues around the facades and how you deal with the mast climbers. So, complicated facades mean complicated arrangements of the mast climbers, and therefore, more complex construction requirements for the contractor to deal with. Now, that's not to say that all buildings should be flat, straight, even, and square, because that's clearly not what we do as a practice. But it's just something to be aware of. How is somebody actually going to lift that piece of facade off a mast climber, and onto the facade. Does it need 2 people? If it's 2 people, do they need extra lifting equipment to help them? What is the material of the facade? Is it a heavy material? If it's so heavy that it needs the crane, how are you going to manage that work while the other crane is delivering modules onto the building? Can you fit 2 cranes onto the same site simultaneously? So all of this needs to be considered at a fairly early stage, so that you can work out how the construction process will happen. And this obviously needs to be done with the contractor, and we try and ensure that we are working or talking to the modular manufacturer at stage 2 of the construction process, because if you leave it too late, then some of these important issues may not be considered in time, and you end up with a building which is, more expensive to deliver than it would otherwise have been had you had that discussion with the contractor installer team at the right point. Generally speaking, different materials tend to get used for different heights of buildings. So, at the extreme end, and particularly now with sort of fire performance and fire regulation sort of dominating the discussion, most of the medium to high-rise buildings that are being built at the moment are of light gauge or steel, hot rolled steel, perhaps with light gauge infill, or concrete with various panel systems. So each building typology and each construction methodology has a different impact. So, for example, in Singapore, they like to build, or they are currently building, quite a lot of modular buildings, volumetric modular buildings out of concrete, and those modules are usually in the range of 40 tons, 30 to 40 tons, whereas the hot rolled steel and light gauge steel modules that we work with are rarely much above 20 tons. And going from 20 tons to 40 tons means a significantly bigger crane. So then you're down to the question of, can you actually get that crane? Is there a crane available capable of lifting that load, and can you get it for the 3 months, 6 months, 2-month period, or whatever it is that you need to deliver the building? So again, it's just highlighting the importance of having these discussions with the contractor and the installer team at an early enough point in the process to enable these conversations to happen, because they can have a big impact on the commercial viability of the project. So I'll show some photographs of sort of, projects completed and in progress, just to show the sort of scale and different of typology of buildings that we've built over the last sort of 15 years or so, all out of volumetric modules. And there is quite a lot of difference in facade between the buildings, and there's quite a lot of difference in heights and shapes. So I suppose this is sort of making the point that not all buildings should be the same. Not all buildings are the same, and even if you're building them with the same construction methodology, there should still be room for development, room for change, room for different typologies. So this is George Street in Croydon, otherwise known as 10 Degrees, and this is completed about a year ago, and it now has a rather slightly taller neighbor, which is being completed since this photograph was taken place. And this is used about 1,500 modules to build 546 apartments for rent on the site, and those modules were fully complete internally before being delivered. So kitchens were in, bathrooms were in, tiles, decoration, etc. So it's a matter of connecting modules to each other and connecting back to the core. And the diagram there shows the arrangement of the core, and you can see some thin corridor modules were used in this case to deliver the building. And because this is a building that is built built as a full rental scheme, the benefit in terms of speed was crucial to the business plan for the client. So Greystar, an American build-to-rent investor, was very keen on the faster delivery to site for this building, because it meant that they could then rent the building sooner, they could pay back their borrowing sooner. So there's a direct relationship between the sort of the logistics of delivery and the business case for the building itself. And that tends to be a similar story with many of the buildings that we work on, that either it's a student accommodation that has to be finished in time for the student year, and it's really not much use to anyone if it's a month late, because then you have to rehouse 150, 200, 300 students. So there is a absolute deadline by which the building must be delivered. So this just shows the sort of arrangement of typical apartments and how those apartments were split up in terms of modules. So even though there are different uses, in some cases there's a bedroom and a bathroom, or a bedroom and an ensuite in the same module, or a living room and a kitchen. And while each one of those is different internally, remember that this is in the two wings of the building, it's 36 stories and 44 stories. So there's quite a lot of repetition vertically. So the manufacturer has to make 44 or 36 of each module. So that gives the factory time to get really quick at manufacturing. And what happens generally is that the speed of delivery increases. So at first, something that will take them a day to do, by the end of the 40 modules, it'll take them half a day, because they've just worked out how to do each activity. People, will sequence the work between themselves to make sure that they get out of each other's way. So the workforce in the factory just learns what is the quickest way of delivering that particular piece of work on that particular module. One interesting problem we had to deal with on this particular project, which is unusual, was that we had two independent cores. And you can see in the second image that there's a connection between the cores. And that was to make sure that as the building was built and as the modules were connected to each other, that the independent cores weren't whipping in the wind independently of each other, that they were swaying in the same way, so that there were no additional stresses placed on the modules that wouldn't be placed on them after the building was complete. So there's a sort of temporary connections between the cores to make sure that everything was going to stay in place. So some photographs here of modules being lifted onto the site, which sort of show a few interesting things. So on the left-hand side, you can see it being lifted off the truck, and those men are not going to stay on the module as it's lifted into the air. So what happens? They lift the module off the truck temporarily, and they check the loading on all the cables to make sure that the module is being lifted horizontally and that there is the correct weight on each of the gauges. You see there are 3 gauges hanging off the lifting rig, so that the module is being stressed evenly across the module, because by lifting it at an angle or by lifting it with different stresses at different points, you're increasing the danger of bending or perhaps cracking in the module. So a lot of care goes into the movement, or should go into the movement of modules, because not every manufacturer and installation team are equally skilled or knowledgeable. So it's very important that large loads like this are lifted horizontally and evenly, so that you're not putting stresses on the structure of the module, which are different to the stresses that are going to be placed on the module when it's placed in the building. So in many ways, loads like this or modules like this are more stressed in their movement to site than they ever will be in position on the building. So quite a lot of care is taken to make sure that those stresses are minimized. And the team on the ground then direct the crane, and then there's another team on the roof of the building where the module is going to be placed. And it's usually a team of sort of 6 to 8 people who manage the installation, and then there's an immediate fix of the module. And about 40 minutes later, another module is ready to be lifted into place alongside it. So the lifting sequence, certainly on our projects, is quick. So you see here the module or another module then being craned into place. You can see that it's weatherproof on the outside, but you can also see that there's a corridor. So back on the plans, this is one of the ones which has a bedroom and a bathroom. So that's a corridor between the two. And you see the corridor is left a little unfinished. And that's because the connections to services have to be made between the modules. But as much of the ductwork and pipework is placed in the modules as is possible. So that's then lifted up and placed into position. And each module has its own identifier to make sure that it's placed in the right location on the building. This was an unusual project insofar as we had 2 cranes running simultaneously. So there were two sets of deliveries, 2 sets of cranes, both working independently to some degree. But both buildings tended to raise by sort of 5 to 10 story increments, so that there wasn't a situation where one was significantly taller than the other. And again, this was to manage the core movement. So some other images of the building in place. And then also worth noting that on this particular project, we used an aluminium carrier system for the facade with smaller panels, which were then installed. So you had a lightweight carrier system for the facade elements, and then you had heavier panels, which were then fixed from the mast liner into the facade system. And here are some examples of the different cladding systems in place on the final building. So again, a lot of this was done to make sure that there isn't that things like daylight and overheating and so on are managed from different aspects of the building, and that we're not using the same approach for every single part of the building. Some more images from a distance, some interiors, some information on the embodied carbon. So even with all of this work being done in the factory, these buildings are coming in lower than benchmarks against that we're comparing ourselves against. So we're pretty confident that this is a clean and green way of delivering buildings. And then some other examples, which I don't think I'm going to talk about very much, but just some other examples of different buildings, shapes, and sizes and types, just so you can see that it's not really one size fits all. There's quite a lot of variety in the sort of construction and in the sequencing. I suppose one thing to say about this building is that this building was built using one lane of the adjacent road. So essentially, one lane of the adjacent road was taken over as the construction delivery point, and then trucks would drive onto that spot, and then it was craned from there onto the building. So the building itself covered the entire site. So one of the ways in which you can develop very constrained urban sites where you're going to build on the whole site is by using this approach. And then you have I think in this case we built the building in 11 months. So you have maybe an 8 or 10 month period where you get permission to close one lane of the adjacent highway, and you use that as the launch point for all the deliveries. And that's an approach we've used in other places on other buildings. This is one on a Holloway Road, so this is a very busy artery, and again, one lane of the adjacent road. I think we can see it here. Yeah, so one lane of the adjacent road is taken up by the trucks, and they pull in beside the building, and the modules are lifted off onto the building. And this building was built in 9 months. So sort of an extraordinary achievement to build, building of any scale really in 9 months, and building it on a site which has got, the Holloway Road on one side, a 2-lane road on the other side, and the tube line running along one side of the building. So it's basically sandwiched between three constraints. So there was a sort of a constant watch from London Underground and TfL on the crane to make sure that there were no oversailing of the railway line and so on. So it kind of illustrates that even in the most difficult, complicated sites, that this kind of approach can actually enable buildings to be built in ways that are probably impractical for traditional construction methodology. And then finally, just on this one, this is another student building in Ilford, which was recently completed, and this was built during the pandemic. So again, because of the way in which factories can organize themselves, and because most of the work was being done in the factory, it had a very short additional delay, because there was a period at the beginning where the factory had to figure out how it was going to work around the COVID restrictions, but it was still built, close to its target completion date, and entirely during the pandemic. So just an illustration of the module types. Most of the building is, as you can see, being delivered, and you see here a typical module with its doors and windows and so on in place. But then this used scaffolding, because a lot of hand-laid brickwork. So I think that's enough from me. This is just some slides of College Road, which is the neighbour to 10 Degrees, which is currently under construction. That's how it will look on completion. It's about 80% of the way there at the moment, and reasonably complicated building. So I think I'll stop sharing at this point, and then we're open for questions.
Yeah, great. Thank you very much, Rory. Really, really interesting. I've learned a lot from that presentation. I've got lots of questions. Audience, if you've got any questions for Rory, we'll try and deal with them now before the end of the session. Please use the Q&A box in at the bottom of your screen. So, Rory, there are a few things that I've been scribbling furiously at some of the things you said, and I wanted to go first of all to the early engagement, and I suppose it's a two-part question from me. You were talking about ideally being engaged at stage 2. So I suppose the first part of the question is, are you often able to get involved at stage 2, or is that sometimes a barrier to be able to bring your knowledge in?
Well, I would say that that a lot of the projects that we've built successfully, we've known from a very early stage, stage 1, which direction the project was going, because if it was a hotel or a student building or a building for rental, there was a strong business case for going down this route for all sorts of reasons. For certainty of delivery, having a shorter program than traditional, early return of the capital investment, and so on. On other projects, I would say, where it was discussed, on other projects where there was less of a driver, then it's sort of 50-50 as to whether or not you end up going down this route or not, or in my experience, because the sort of point at which you normally engage, so the industry is used to engaging with contractors post planning, by which time it's really far too late to have any major impact on how the scheme is going to be designed and how that design relates to the construction methodology. So if you're making a big change in the construction methodology, you need to have an early engagement. That's pretty much, I think, how it works. and making the decision at stage 3 or 4 to change. It's possible. We've done a couple of buildings where we have changed them, but that was in cases where the buildings were reasonably well designed to begin with, and were kind of, it was possible to make the change. They weren't super complicated buildings, but that's, and in fact, in both cases, contrary to expectations, we increased the net to gross. So a lot of people say to us, "Oh, surely you lose space." No, you don't. Because there's generally a lot of inefficiency in the sort of concept stage designs.
Yeah.
So
yeah,
it's been uneven, I would say, in buildings that weren't designed from scratch, because change is difficult. People find it hard to change.
I suppose another part of that question is the RIBA DFMA overlay.
Yeah.
Talks about the appointment of an MMC advisor. So in that particular type of discussion, are you there as potential architect, or are you there as MMC advisor, or are you wearing two hats?
Usually we're there as both. We're there as both. And we don't, I mean, I understand why the MMC advisor sort of, idea, but to be honest, most of the buildings that we've delivered have been delivered by us working with the manufacturer. So the idea that you need another party in between, I think that should probably only be a short-term thing. While people are learning how different systems work, I think once they've done a project or two with different systems, they should understand them well enough. And actually, the best place to get advice, in my experience, has been directly from the manufacturers themselves, because they know their system, they know how the system is going to be delivered, they know how it's going to work. It's only if you're doing a feasibility study at an earlier stage where you think, well, how could we deliver this with panel systems and pod systems and so on, that's when I think an MMC advisor is helpful if you don't have the expertise in-house.
Yeah. So I suppose the third and final part of that question is, when you are having these stage 2 or even earlier discussions, do you feel that you have the competencies to know enough about logistics and enough about the manufacturing process, or do you take in external logistics companies and external manufacturers to those early stage discussions?
We generally take in the external manufacturers if we can, if we know who they are, or if we can persuade the client to engage, because generally speaking, the manufacturers are the ones who deal with the logistics. So they have the expertise from a manufacturing point of view to know what logistics companies they might use and what approach they might use. Excuse me. The last remnants of COVID still sort of hanging on. So it's generally we start with the manufacturer rather than with a logistics specialist. So, but also, I think we have a lot of experience now. At least we know the questions to ask. And that's half the battle, really, knowing the questions to ask. Those questions can often be answered by a wide variety of different people, but it's the questions that are important.
Okay, thank you. I've got plenty more. I'll take one from the audience. In your experience, what is a typical reduction in the number of workers needed on site using the method shown, and any benefits or problems linked to this?
At a guess, and it's very difficult to have a traditional project and a volumetric project delivered at roughly the same at the same scale, delivered at the same time-ish, to make these direct comparisons. But loosely speaking, we think it's about 80% less. So on some of our buildings,
is that 18 or 80, Rory?
80.
80. Okay.
80. So at completion stage, we might have maximum 40 people working on a construction site for a building. Whereas, on a traditional building, you would have, hundreds all the way through. And sometimes we're down to sort of 6, 8, 10 people working on site. And there's 150, 180 working away in the factory. And then for for the basement and foundations, it's pretty similar to traditional, but that's a relatively small proportion of the overall build. So if the factory tends to produce between 80 and 85% of the work, and that's where the reductions come from.
It's remote.
Yeah.
Yeah. Thank you for that question from the audience. One of the things I'm interested in, I was talking earlier this week to an expert in logistics who had come from a different sector. He'd come from automotive and other sectors. And he was talking about the way that we deliver to site. We tend to bring in, whether they're components or modules, they tend to be wrapped, and we have an awful lot of wrapping and materials that we then need to dispose of. Is that something you have to take into consideration?
Well, I think as you saw from the ones that we use, there's the modules tend to be finished externally and don't need another layer of protection.
That did strike me when I saw the pictures.
Yeah. When there are openings, you tend to have a plastic sheeting covering those, but that's a relatively minor, a minority of the module types, I'd say. But I know there are other manufacturers who wrap them in plastic, which then need to be removed. So I think this is, again, a temporary situation, and I would hope that over time that either those wrappings would become part of the building or would be gotten rid of entirely.
Certainly, I've spoken to manufacturers where they feel they need to wrap them, but then when they have the problems of having to store them perhaps for longer than they anticipated, is that wrapping sufficient to protect them for that duration? Should they be thinking about reusable wrappings? So when I saw some of the photographs of yours, it did strike me that it was minimal amount of packaging.
Yeah, but I think on at least one of the manufacturers we worked with, Elements Europe, they use a reusable wrap. So they take it away, bring it back to the factory and reuse it. So it's not that complicated a task, because you've got a truck going back to the factory. So it's not as if you have to get somebody else to deliver it back. The truck is going back. So anything that you can reuse, you've got an easy way of doing so. But absolutely, I mean, taking waste out of the process is absolutely what we should be doing.
Yeah, thank you. I guess the other thing that struck me, particularly in high-rise volumetric modular, is understanding the structure of the individual modules. So, are the ground floor modules bearing the dead load of every module above? Okay,
yes.
So I suppose two questions. A, how does that increase the structural requirements on the ground floor? And B, do those structural requirements lessen as you go up, and do you design the upper stories differently?
Yeah. So we try and design it so that it doesn't have much of an impact on the spatial arrangement. So we try and do that by using different thicknesses of steels, rather than by having bigger columns at the base and smaller ones at the top. We sometimes have to change the column size as well. And we would tend to do that in sort of sections. So you may have like 10 floors of one section, 10 floors of another section, 10 floors of a third section. So the sections get lighter as you go up the building, because otherwise you're wasting structural capability, and steel is not cheap. So and also you're imposing greater loads. The more tonnage you have up, the more you're imposing loads at the base. So yes is the answer. So although each module might look vertically, each module might look identical, there are subtle differences, particularly in the structure.
Yeah, thank you. Another question from the audience: do the current factory locations limit the viability of buildings in certain areas because of the increased distances and delivery costs, or is that not a significant enough factor in the overall cost?
It hasn't. So far for us, that hasn't been a deciding factor. So we have factories in the southeast and we have factories in Yorkshire. There are several buildings in London that have been delivered using modules from Poland and from Latvia. And there are several buildings in New York that have been delivered using modules from Poland. So shipping is relatively cost effective and cheap. Road transport is more expensive. So I remember, somebody explaining to me that, having a module shipped from Poland to New York was cheaper than having it built in, say, Idaho and trucked to New York, which seems utterly bizarre, but those are the economics of transport. So we don't. I think the deciding factor that decides whether or not a project goes modular or not has much more to do with all sorts of other factors than logistics to date. I think in the future that may change, but at the moment, it's rarely a deciding factor, if ever.
Okay. I must a shout out for my colleague Naomi, who's on this call. She has considered the locations of factories and how do we bring social value to volumetric modular projects if indeed we're taking away work from the location of the site. And that report was published at the end of last year. And she's currently working on a report to look at the embedded carbon in various systems. And of course, I guess the distance of transportation from factory to site may well be a factor there. But it's a really good question. So thank you, whoever asked that. Mark Stevenson in the audience. In your experience, do the modular manufacturers provide consolidation or storage solutions to promote last mile constrained deliveries?
Again, I would say that we're not at a point in the industry where we have enough projects happening simultaneously to make that sort of a thing. But we have had discussions with at least one local authority about the wisdom of setting up something of that nature. So the need for having buffer spaces, or the need to have a consolidation point where multiple elements come from different places and then could be partially assembled before being delivered to site. So that is relevant to all sorts of interesting uses. But I think you would need a specialist facility, and I think there is definitely room in London for several of those. I don't think we've got anything like it yet, but as I said, we've had discussions with at least one local authority about the practicalities and wisdom of setting up something like that. So I think it's a matter of the manufacturers working together more, probably to share knowledge and need and demand and so on. And then in the near future, we have this PAS 8700 being started by BSI, which I think is going to help to bring better definition to offsite systems, so that may help to highlight where there are common approaches that consolidation center can help.
Okay, thank you very much, and thank you, Mark, for the question. The time I've just noticed has gone really, really quickly, and we are coming to the end of this session. So I'd like to thank everyone in the audience for attending and asking Rory questions. Particularly like to thank Rory Bergin from HTA for an absolutely fascinating presentation. Someone with absolute real-world experience in offsite, particularly volumetric modular design. Certainly, I've been in this arena for more than a decade, and I've learned an awful lot listening to you today, Rory.
Thank you.
So what I would do is thank you very sincerely for that. I'd remind you in the audience, there is a whole vast library of resources around offsite on our school. So I'm sure Naomi will follow it with the various links. But in the meantime, if you would take a moment to fill in the feedback form, telling us what you thought of this session, what we did well, what we didn't do so well, so that we can continue to improve. Meanwhile, many thanks sincerely again. Thank you, Rory. And this session is now closed. Thank you all.
Thank you all. Bye-bye.